This lesson goes over how to find your domain algebraically. So the domain, as a reminder, is the x values or the values we put into a function. We're going to work on finding the domain algebraically. That means that we are going to use the equation to determine the domain. We are not looking at the graph. There are certain functions that have restrictions on what values can be put into the function. If there are no restrictions, then the domain is just from negative infinity to positive infinity. The first function that we're going to look at that has a domain restriction is our radical. So if you had an equation like y is equal to the square root of something, whatever the value is underneath of here, this number has to be positive and it is allowed to be equal to 0. So whatever number is in there has to be positive or equal to 0. So we're going to take whatever is underneath of that radical and we are going to set it greater than or equal to 0. We will then solve for x and that will give us our domain restriction. Our second type of function that has a domain restriction are fractions. So we have 1 or whatever in the numerator over the denominator of a fraction. Denominators of a fraction can be anything, but they are not allowed to be equal to 0. So we're going to take that denominator, we're going to set it equal to 0, and then we're going to solve. And whatever value we get, it's not allowed. We can also have a situation where we have a combination of radicals and fractions together. So you might have something in the numerator and then a radical in the denominator. So because we are underneath of a radical, we know that this number has to be positive and that it could equal 0. But because it's underneath that radical, it actually cannot equal 0. So the denominator and radical is a combination of both of those things. So when we solve for this or domain restriction, we'll take whatever is underneath the radical, and this time we will just say, hey, you have to be greater than 0 because you're not allowed to equal 0 in the denominator. All right, let me show you some examples. All right, so our first function is g of x is equal to the square root of x plus 4. Whatever is underneath of here is allowed to be positive, and it also can equal 0. So we're going to take what's underneath of there, and we're going to say, hey, you have to be positive or equal to 0. So now I'm going to solve this. I'm going to minus 4 from both sides, and we get x is greater than negative 4. So as long as our x value is from negative 4 to infinity, x is greater than negative 4, then it's okay. If we put a number in there back into this x value that is less than negative 4, negative 12, we're going to get a negative, and you can't take the square root of a negative. So the domain of the function g of x is equal to the square root of x plus 4 is negative 4 to infinity. In this example, we have a fraction. The denominator of our fraction is not allowed to equal 0. So we are going to take x minus 1. We're going to set it equal to 0. We will solve this. We're going to add 1 to both sides. But it's not allowed to equal 1. So x can be any number in the entire world except for 1. So x can be negative infinity to 1, and then 1 to infinity, where we're not including 1. And that's why we use those parentheses. The details are really important. Here we have a combination problem. So we know because we're underneath a radical that this has to be positive, and it can be equal to 0. But because it's in the denominator of the fraction, it is not allowed to be equal to 0. So when we set up our inequality, it is not going to be equal 0. So then we can solve. I can minus 4 from both sides. I can divide by 2, and x has to be greater than negative 2. So the domain for this function, we're going to use a parenthesis, negative 2 to infinity. All right, one more example. Here again, we have a fraction. So this is not allowed to equal 0. So I'm going to set this equal to 0. And then I'm going to solve it. We have a quadratic. So as a reminder, there's 4 different ways that you can solve a quadratic. You could do quadratic formula. You could factor. You could do the square root method. Or you could complete the square. I think I'm going to factor. This is difference of perfect squares, so this gives me x plus 2, x minus 2. When we're solving a quadratic, we set each factor equal to 0. I'm going to solve, so I'm going to minus 2 from both sides. I'm going to add 2 to both sides. And now we know that we are not allowed to equal these numbers. So we're not allowed to equal negative 2 or 2. So the domain is negative infinity to negative 2. We're not including negative 2. But then we can include the number right after negative 2 to 2. And then from 2 to infinity. So that domain is saying every number from negative infinity to infinity except for those 2 values. And those 2 values, if you would plug it in here for x squared, x2 squared minus 4, that would give you 0, not allowed. Negative 2 squared minus 4 would also give you 0, also not allowed. So there are 3 major functions in this class that we talk about with a domain restriction. When you have a radical, when you have a fraction, or when you have a combination of those 2 things. Remember, if you don't have a restriction, if it's not one of those things, then your domain goes from negative infinity to positive infinity.